We're breaking lesson 7.4 up into two parts. We started off by looking at elimination where we had to multiply by something first, and now we're going to look at the best method for solving any system equations. So you get to pick. The first thing we looked at in this chapter, to graph, we could estimate the solution. And we saw in the GeoGebra activity that to get an exact solution, you need more precision than graphing gives us. So not the best method. It was a good place to start, but substitution or elimination is going to be our go-to. Substitution is if one of the variables has a coefficient of 1 or -1, is really easy to solve for. Elimination with addition, we're looking for opposites. And subtraction, we're looking for those coefficients to be the same, so we can subtract and get 0. And if we don't have opposites are the same, then we can multiply first and then get either opposites are the same and go from there. Okay, the directions are going to say something to the effect of determine the best method to solve the system equations, then solve. Okay, I have coefficients. These are different, but these two are the same. So this would be a perfect time to use elimination with subtraction because the coefficients are the same. So if I subtract 5x minus 3x, I get 2x. My y's cancel out. -2y minus -2y is no y. And 12 minus -2 is the same as 12 plus 2 is 14. Then I can divide both sides by 2, and I have my x. I'm halfway there. So if I go back to, I may as well just use the first equation. And where there was an x, I'm going to substitute in what we found that x equals. So 5 times 7 is 35 minus 2y equals 12. Now we can subtract 35 from both sides of the equation. We end up with -2y equals, it's odd, -23. When we divide by -2, it's not the end of the world. So it looks like my ordered pair is going to be 7, 11.5. It's always a good idea to substitute back into our original equation, make sure it works. So 3 times the second equation, 3 times x is 7, and minus 2 times the y we found was 11.5. The question is, does it work? I have 21 minus 23 is in fact -2. I am happy. I know that is right because it works for both equations. Now, I don't always make you guys show that second check step. I do it in your head. It's great. In this system of equations, I don't have any coefficients of 1, and I don't have any coefficients that are the same or opposite. So I'm just going to have to do elimination, but I'll have to multiply first. Now, I think most people prefer adding opposites. So I'm going to take that first equation, everything times 4, and the second equation, I want to take everything times 3, and then I'll get 12s. Well, a 12 and a -12, which is lovely. So I have 16x plus 12y equals 76, and 9x minus 12y equals 24. When I add, I'm getting kind of largish numbers, but that's okay. 25x equals 100, and when we divide both sides by 25, we get x equals 4. So when we substitute that back in for x in our first equation, we're going to get 16 plus 3y equals 19. Subtract 16 from both sides of the equation. So 3y equals 3. Divide by 3, and we have y equals 1. So I'm going to show you guys substituting back into that second equation because it's really important, even though I let you guys not write it down and just do it in your head. 3 times 4 is 12, minus 4 is in fact 8. I know that it works for both equations. I am happy my answer is right. I don't need the odds in the back of the book. And this time I can see I have a coefficient of 1. So that first equation is going to be easy to solve for x. I can just subtract 5y from both sides of the equation, and I have x equals 4 minus 5y. So going to the second equation that I wrote on a bit, I have 3 times what equals, x equals 4 minus 5y, minus 7y equals 10. So now I can just distribute, so I'll have 12 minus 15y minus 7y equals negative 10. Combine my like terms, so 12 minus 22y. Subtract 12 from both sides of the equation. And I like the direction this is headed. Divide both sides by negative 22, and y equals 1. So we can go back to our x equals equation, and we're going to have x equals 4 minus 5 times 1. So 4 minus 5 is negative 1. So we have the ordered pair negative 1, 1. I'm doing the check step again. So we have 3 times negative 1 is what I found for x, minus 7 times 1 is what I found for y. So when we multiply it out, we're going to have negative 3 minus 7 does in fact equal negative 10. It works for both equations. My ordered pair is good. Of the 5 different methods for solving equations, we're rarely going to use graphing when we're serious about doing it. Substitution works well if one of the variables has a coefficient of 1 or negative 1. Elimination with adding if you have opposites for coefficients of one of your variables. Elimination of subtracting if 2 of your coefficients are the same for the same variable. And if we don't have either the same or different or coefficient of 1, we're going to have to multiply and make it be one of those things.